Hello everyone, my name is Siddhi Madne and I am engineering student pursuing from Shivnagar Vidyaprasarak Mandal College of Engineering Malegaon. I would like to thank Emertxe Information Technology to giving an opportunity to automotive embedded internship and making a project on real-time electric vehicle telemetry and driver assistance system, real-time EV monitoring and ADAS. This project focuses on building a real-time EV monitoring system using the STM32 Blue Pill microcontroller. The system continuously monitors important vehicle parameters such as vehicle speed, then battery SOC, motor temperature and torque. It also implements ADAS feature like collision detection and blind spot detection. The processor data is transmitted through UV and display on a live Python dashboard for easy monitoring. Then project objective. The main project objective of this project is to design an EV monitoring system using STM32 Blue Pill. We interface unlock sensors through the ADC, calculate EV parameters such as speed, torque, battery SOC and range, implemented ADAS algorithm for obstacle detection. Finally, all the information is transmitted through the ultrasonic and display on a Python dashboard in real time. Electric vehicle and ADAS feature. Electric vehicles are more energy efficient, require less maintenance and produce zero tailpipe emission. To improve safety, we implement advanced driver assistance system features including forward collision warning, blind spot detection. Then next slide, software and hardware stack. For firmware development, we use STM32 Cube IDE. PicsimLab was used to simulate the STM32 Blue Pill. Then Python was used to develop dashboard, Terraster, VSP and PySerial handle UART communication. Then hardware side, the project uses STM32 Blue Pill, 3 ultrasonic sensor, then potentiometer, LEDs, and Python were the programming languages used throughout the project. And then phases of my project. My project first developed involvement in this project. I have learned a lot of things, like let me tell you in brief what I learned during this project. It's kind of a learning project, learning STM32, how to set up STM32 Cube ID, how to set up the PicsimLab, what is PicsimLab, used for Python setup, then GPIO peripherals, how what is GPIO, how we set up GPIO pins, LED buzzers and all that I use in this project. Then ultrasonic ADAS engine, this is EV, this is left sensor, this is right sensor and this is front sensors. All these measures by the ultrasonic sensors, and then accordingly to that we will get the warning, right? If the front distance is less than 50 centimeter, we will get the warning, or if the front distance is less than 20 centimeter, I mean we will get the warning, but it's not a warning, it's a critical warning. We will see in the demo, right? And then blind spot detection active when it's less than 30 centimeter or speed is greater than 20 kilometer per hour. This is 20 kilometer per hour. Or time to collision warning if it's less than 1.5 second, we will get the trick critical warning. So this is the whole things, that all this. And then next slide, fault detection and alarm priority system. We will get the alarm when we think are not in, if certain things are less than threshold, or what code I write in my code logic. According to that, fault detection started, one out detection started, and we will give the alarm, like it will basically fair fault. I have implemented 4 fault: OT with motor temperature, then is fault SOC and the fault collision. Fault common time, this is the fault which I have implemented. This is full fault, that alarm none, then alarm advisory, alarm warning, and then alarm critical that I have used. Then UART telemetry protocol. So first EV telemetry from this is speed, SOC, then torque, temperature, range, acceleration, and brake. All this will calculate by the physics formula, and all the data come from potential sensor. This is all the sensor data, potentiometer sensor data. This is the ultrasonic sensor data. On this, then left distance, right distance, time to collision, and blind spot detection, and the fault. Then at the last, successfully implementation of my project. The project successfully demonstrate a real-time EV dashboard with STM32 simulation, Python visualization, UART communication, collision detection, blind spot detection, and on alarm system. The main advantage of this project are real-time monitoring, improved driver safety, low cost implementation, modular architecture. In the in this project, the future in future I implement can be extended with canvas, GPS, IoT, connectivity, AI driver assistance, and camera vision for deployment in real electric vehicle. Then lastly, now let us begin the simulation of EV ADAS.
I have already, yeah. So this is my PicsimLab, and I have already set up all this. So acceleration pedal, brake pedal, acceleration and brake pedal associate motor temperatures. If I increase the acceleration pedal, battery get this decrease. If I increase the brake pedal, my battery get charged, and yeah. Right now I'm not getting any alarm because everything is good. So what I'm getting, a front distance is 272, all this data is printing here, and this is the same data which I can show you. If I increase the motor temperature, I will get the alarms, I will get the alarm. So this is the advisory alarms I am getting, right? The fault one, this is all data we can directly see to the here. Let me do this. Yeah, this is the already 103 km per hour speed, and this is our batteries 65.8%, torque is zeros, and acceleration is 47%. Motor temperature is so hit, let's just see it, and alarm is, but it is not exceeding 90 degrees, that's why it's not saying critical. And the faults, and this is our front distance 380, so there is no collisions right now. So if I let me change the parameters. First reset it, and then yeah, decrease this and increase this accelerations. Increase this. Yeah. I'm getting the, if it's less than, if it's 30, I'm getting the red alarm. Okay. So let's see it. I'm getting both fold. Front distance is this. Speed is right now. Speed is increasing a little bit. So slowly speed get increased, and yeah. Let me first reset it. Okay. Yeah. It's getting now get back to 0, and alarms is critical, right? So because I have set a speed not from the initials is 0, I'm not setting to 20s, and all threshold is already 0. So, and this is my code. This is my code which I have, this is my main project code, and this is my learning project, LED blink and all that. ADC test. So this is my main project code. So yeah, this is every dashboard, ADAS, ADAS H, everything I have included. This is our ADAS parameters logic code. This is my main.h and then main.c, everything is here. So this is my whole code, and this is my Python logic code, and yeah, this is the thing. And so yeah, if it's collisions because front distance is less than target, that's why we are getting the alarm is criticals and battery is 30% and speed. Let me go this first. Increase the speed and let me increase the acceleration. So this is the whole project, and now speed is slowly increased because I've set the threshold which is increasing very slowly, that's why. So now there is no alarm. The alarm is getting none. So this is the whole project. I hope you understood my project, what I have did in this project, and I had a lot of learning during this my internship. And thank you for watching.